So, number 4, here's our review. So, I don't need to do 1, 2, and 3. I think you guys can probably handle that. But let's look at number 4, possibly 5, and possibly 6, okay? But let's look at 4 for sure, okay? In 4, you got triangle ABC has 2 possible solutions, okay? So, first of all, the measure of angle A is going to be 30 degrees. B is a 6.5. We're going to go in centimeters. And little a is going to be 4 centimeters, okay? So what I need to do first is draw this out. So I need to draw angle A, so I'll put a little point here, call it A. Okay, let's just start there so I can make angle A. And when I draw the terminal side, I don't know how long it is, so I'm just going to draw this nice and long, and I'm probably going to have to erase some of it. I don't know how long this side is. I have no idea. So I draw on the terminal side. It could be 10 centimeters, it could be 5 centimeters, I don't know. I'm just going to draw it in. And as I create the triangle, I'll eventually know how long it is and I can erase it, okay? Now I need a 30-degree angle for A, so I'm going to use my protractor, zero it out on angle A, find 30 degrees, I'll make a mark. And then what I think is handy is to make this side B. You can do it differently, you could make this side B. It can be done that way, but then your drawing would be upside down from mine. Not incorrect, just different, okay? So I'm going to make this B, which is 6.5. So I'm going to go ahead and draw this side 6.5 centimeters. 6.5 and call that little b. Make that 30 degrees. So I like to label and mark my triangles as I go. Now, little a is going to be 4. So if I put a 4 in here, then the 4 is going to come off of this piece here, because little a is going to be directly opposite of angle A. Okay, so then I told you it's going to have 2 possibilities. So one, the 4 would hit right about there. Okay, so that's little a at 4. And then, and we won't draw this one in yet, we'll wait till we do it. There is a possibility of drawing the triangle right there. So there really are 2 possible triangles. We'll come back to that one, all right? So right now, let's just go ahead and solve the bigger triangle, right? So let's mark in the bigger triangle. So we'll just call this the pink triangle or the purple triangle. So some of the things I know, let's label it. If this is little b, that's angle B. If this is A, we got little a, so this has to be angle C, ABC, which makes this side little c, okay? Now, I've got a pair of opposites. I have a pair of opposites, which means I can use the law of sines. If I have my opposites, then I can use my opposites here to find angle B. So right off the bat, let's find angle B. So we'll go the sine of B over its opposite side, which is 6.5, equals the sine of 30 over its opposite side, which is 4. Okay, I will multiply up the 6.5 to solve it. Solve sine B is equal to 6.5 sine of 30 divided by 4. I use my calculator. I'll go 6.5 times the sine of 30 divided by 4, and I should get a decimal, which I do. And then what I'm going to do is just simply take the sine inverse of that, because I need the angle, so that angle B is going to equal sine inverse of this, sine inverse of that answer, about 54.3. So angle B is about 54.3 degrees. Okay, circle that. There's one answer. So once I get the 54.3, then angle C is pretty easy from 180 degrees. So angle C should be fairly easy to get. Just some geometry, not even trigonometry. The angle C is just simply 180 degrees minus my 30 plus my 54.3, right? Again, I'll just use my calculator to subtract that. Okay, that's pretty easy. I'll go 180 minus parentheses 30 plus 54.3, and I get an answer of about 95.7. So angle C is about a 95.7 degrees. Okay, circle that because that's one of the answers. Put that 95.7 degrees there. Okay, finally I can find side C by getting the law of sines, setting up my opposite. So I can go side C over the sine of its angle would equal the 4 over the sine of its angle. So I'll just set that up. I'll go side C over the sine of 95.7 degrees equals 4 over the sine of 30. Cross multiply, I'll bring that up there, right? So I have a C is equal to 4 times the sine of 95.7 over the sine of 30. I'm not looking for an angle, so I will not push an inverse button. Only push the inverse button if you need to find the angle. So I'm just going to go 4 times the sine of 95.7, close the parentheses, divided by sine of 30, close the parentheses, and I get an answer about 7.96 or about 8, okay?
So if you were looking for an angle, you'd have to do the sine inverse, right?
Always. Whenever you need an angle, always. Okay? Listen to what Simon said. Whenever you need the angle, when you need an angle, you must always push either sine inverse, cosine inverse, or tangent inverse, okay? Here's why. Inverse means opposite, right? So if you take the sine of an angle, you get a side. The opposite of that statement is this. The opposite, or the inverse, is if you have a side, you get the angle, the inverse, right? So the sine inverse of a side gives you an angle. Does that make sense? That's why it works, because it really is the opposite. Okay, now we've got the bigger triangle. Let's look for the small obtuse triangle. So let me go ahead and highlight that triangle. So the other triangle is right here. Because really, that could have been drawn also as far as the directions. If we look at the directions, you know, we would have had angle A at 30. Could have had B at 6.5, and little a could have been right here at 4. And so, really, this could have been the triangle drawn. This part of the triangle might not have been drawn at all if you didn't see it, right? So there really are two possible triangles with the given information, okay? So, first of all, let's take a look at what we have. This is 4 and this is 4, which makes this an isosceles triangle. I like that because if it's an isosceles triangle, then that side is equal to that side, which means this angle has to go to this angle. Well, angle B is really not really there anymore because if I just draw the yellow triangle, then angle B is really there now, isn't it? Okay? So, angle B then, if that's 54.3, then the angle B I want is that obtuse angle, right? So let's say, okay, angle B is just simply 180 degrees minus my 54.3. All right, because 180 degrees for a straight line, right? So I'm just going to use my calculator and go my 180 minus my 54.3, and I get an answer of about 125.7. So angle B is about 125.7 degrees. Okay, good. I'm going to write that. I'm going to circle it because that's one of my answers. And I'll even label my triangle so it makes it easier for me. Okay, 125.7, right? Okay, angle C. All right, now angle C is a smaller angle, but it's still the same process. We're still going to take from 180, right? But it's just that little one right there for angle C.
So why would you take from 180?
For angle B, straight line, right? So if that's 54, 180 degrees for a straight line.
Why would you for C?
Oh, how many degrees are in a triangle? Right?
Yeah.
180, that's okay. So I'm just going to go 180 minus parentheses, my 30, plus 125.7. Let's see what I get, okay? So I'll use my calculator. So clear, we're going to go 180 minus parentheses, we'll go our 30 plus our 125.7. And I get an answer about 24.3. So angle C is about 24.3 degrees. Circle that. It's an answer. Okay, so that's right there. 24.3. Okay, then finally we'll do the same thing. We'll set up for a little c because that is little c. We'll set the law of sines. Okay, so little c over the sine of its angle will equal the 4 over the sine of its angle. So we'll set it up again. Same way, so we'll go little c over the sine of 24.3 because that's its angle is equal to my 4 over the sine of 30. Cross multiply, bring that up there. So that c is equal to 4 times the sine of 24.3 divided by the sine of 30. And again, like we talked about, we're not going to hit a sine inverse because we're not looking for an angle, we're just looking for a side, right? So go ahead and use our calculator and go 4 times the sine of 24.3. Always close your parentheses. Always close your parentheses, okay? Divided by sine of 30. And I get an answer about 3.3, really. Now, all right. Now, Nikolai asked a really good question. Why don't I just measure these, okay? And that's true, you could, but I'm going to be looking for work tomorrow, so if it doesn't have the work, you're going to lose points automatically. But Nikolai said, well, I can just measure it if I did a good job drawing. Hey, that's pretty close to 8, which is what I had, right? or the little one, that's pretty close, about a 3.3. Hey, I'm doing a pretty good job measuring, right? See, I got that. Or you could even measure your angles if you really were good. You say, well, what is this angle? Well, that's pretty hard to get 54.3, but you know, for your sides, you could try measuring it with a ruler, okay, and you get pretty close. But I'm going to look for the work, okay, the work needs to be there. Okay, the big trick to this really comes down to, and Simon, you said it really well, you want to know, okay, right there is the big trick for the second triangle. Isosceles triangle, because when you draw it, that side's equal to that side, you've already found angle B, right? So you also know that angle B, because in an isosceles triangle, the base angles are equal. So if you know this is the same, the 54.3, then you subtract from 180 to get the obtuse angle for angle B. So it's this angle B here that you just subtract from 180 from your other B, right? See how that works? Okay, let's take a look at number 5. Okay, all right.
What is that?
Okay, number 5. And I'm going to redraw it because it takes a little bit of work. So let me redraw 5. 5. So I'm going to redraw 5 real quick. It doesn't have to be perfect, just as long as I get the right angles in there. Alright. Hopefully this is the easiest quiz. Trig is not hard. We've got A, B, C, D, 12, 130, and 8. Everybody make sure they put the 90 there, okay? Everybody make sure you make that 90, all right? Okay, so again, what we have is a formula for the area of a triangle. Area is equal to 1/2 the adjacent times the adjacent times the sine of the inclusive angle, okay? So that's a formula that probably ought to be on your note card, okay? Yeah, question?
You forgot the 14 on the bottom there.
Oh my goodness, thank you. I need that, I do. So from here, this is the area of a triangle. So I don't have a triangle. Let's make a triangle. The best way to cut this really is directly this way. You can cut it this way. You can, and you can get the right answer. It takes more work though. It does. If you cut it this way, it takes a little bit more work. Right, but with the 90, it's just nice having the 90 because that's an easy formula, right? So cut it right down the middle. Because if you cut it this way, then you can use Pythagorean's theorem, and you can just use the easy area formula, right? So I'm going to have triangle 1 and triangle 2. So let's go triangle 1, triangle 2. So right off the bat, let's find triangle 1. So triangle 1, we can do it. It's really easy. It's just base times height divided by 2, right? It's a right triangle. So the area of triangle 1 is simply going to be 1/2 my 14 times my 8. I don't need my sine, blah, blah, blah. We already know sine of 90 is 1 anyway, so, you know, it's pretty easy. So that's triangle 1, so let's see, that'd be 56. I don't need a calculator, that's 56. Half of 14 is 7. 7 times 8 is 56. Wow, we can actually do math in our head. See how smart we are. So triangle 1 is really 56, and that's in terms of centimeters squared, okay? I'm going to circle that because I want to come back to that, okay? Now, this particular formula is 1/2 adjacent times the sine of the angle. So if I'm going to look at triangle 2, I have an adjacent side. I don't have an angle. I don't. I've got the 130, but that's not for the triangle, right? I don't have an angle. And I don't have this other adjacent side. So I need to find some things. For me, I think the easiest thing to find is this side DB. Let's call it C. So if I find a little c, we can do that just by Pythagorean's theorem, right? Just set up Pythagorean's theorem.
Should it be called little a?
Actually, you know what? That's a great question. Either it's little a or little c. Yeah. Let's call it little c, though, just because I just called it c, okay? Plus, it goes along with it, like Pythagorean's theorem, doesn't it? Yeah. Good job, Jose. So let's go 14 squared plus 8 squared equals c squared, because Pythagorean's theorem only works on a right triangle, right? So 14 squared plus 8 squared is 260. Square root of 260 is, I don't know, about 16.1, okay? So about 16.1. So let's put that up there, 16.1. So in this particular problem, when I grade it, tomorrow night, I'm going to be looking for a lot of things. I mean, this problem's worth like about 5 points because I'll be looking for that answer. I'll be looking for that answer. Well, that good news and bad news. The good news is that if you get the final answer wrong and everything else right, that's 4 out of 5 points you're going to get. Right? So, I mean, as long as you know what you're doing. Now the bad part is if you don't have a clue what you're doing, you lose 5 points right off the bat, which is pretty significant, right, to lose 5 points. But a lot of this should be easy. You should be able to get triangle 1 easy. There's an easy point, right? You should be able to get C pretty easily, Pythagorean, okay? Now, to get this angle here, okay, call that angle theta. We need that angle because we've got the adjacent, we don't have that angle there. We need to find angle D, all right? And we're going to call angle D is that angle right there, okay? We need to find angle D, so we can subtract from 130 to get the theta, right? So angle D, there's a right triangle, okay? And you guys can use the lost signs if you want to. I actually know how to use right triangle trig, so I'm going to. Opposite adjacent, right? Opposite adjacent, I'm just going to use tangent. So I'm going to go, okay, tangent of angle D is equal to my opposite over my adjacent. Simon, let me ask you an easy question because you're so brilliant today. If I need to find the angle, what button am I going to push?
The inverse.
Exactly. So I'm just going to go tangent inverse of 8 over 14 is equal to angle D. So I'm just going to use my calculator, okay? And guys, make sure you're in degree mode no matter what. That'll really mess you up if you're not in degree mode. 8 divided by 14. And I get about 29.8 degrees. So I'll be looking for that answer also. See, there's another point right there. Now, you're going to find theta. Then to find theta, theta is simply going to be 130 minus this 29.8 degrees, right? Sounds perfect. I'm going to do it right now on my calculator. You're probably 100% correct. 130 minus 29.8 and 100.2. Thanks, Simon. You're totally right. Okay, so that's 100.2 degrees. Okay, now let's look what we have. We do have adjacent, and the inclusive angle, so we can use the formula. So the area of a triangle, triangle 2 is going to be 1/2 adjacent, which is 12, times the other adjacent, which is 16.1, times the sine of 100.2, because that's the inclusive angle. Just use my calculator to do all that. So I'm just going to go clear. I'm going to go 0.5 times 12 times 16.1 times the sine of 100.2. And I get an answer about 95.1. So triangle 2 is about 95.1. So then, grand answer. So you can see all the different parts here. You've got 1, 2, 3, 4, and here comes the grand answer. The total is just going to be the 95.1 plus the 56, right? So plus 56, and I can answer about 151.7. Nope, 0.1. My bad, 0.1. 151.1 in terms of centimeters squared, okay? Okay, so you can see this one's worth a lot of points. But it's not that bad. As long as you've got a 90-degree angle here, it becomes pretty easy, okay? All right. I could do the last one, the bearing one again, or you guys can work on the bearing one, okay? You guys got it? Okay, so let me go ahead and stop the recording here.